Did you do a mic check for the rest?
Remote, can you hear me? Can one of you speak up?
Yeah, we can
Hear you.
Great.
Loud and clear.
So can someone, let's see, Daniel, can you tell me in like the most layman terms, what is object-oriented, compare object-oriented programming versus functional programming? Or what is object-oriented programming?
Object-oriented programming is dealing with objects that you can change. Like they have the same like base kind of properties, but you can change certain things about them to fit use cases. I don't know really.
They have like base properties that, I mean, right, yeah. They have base properties that are kind of, that store data that are unique to that specific property. Something like that. Yeah, and then which is an object, like an actual class, which is the type of object. I like to think of it, so object-oriented programming versus functional program. So up until this point, up until yesterday, you've all just been doing functional programming. Like in your challenges, you're literally just writing a function that's a set of instructions. It doesn't know anything. Like versus object-oriented programming or class-based classes, which stores specific data of an instance. So we've been talking about these instances. What's an instance? I like to think, so a function to open. Like you're writing a function that opens anything, like a box, a car door, a hood, opens a laptop. You can write a function that just opens, like to open, but what does it open? You actually have to pass in data, parameters, arguments that tell you what it opens. And the way you open a laptop is different how you open a car door versus how you open an Amazon box. Whereas if you create a class like Amazon box, you can create a method within that called to open, and that specific to open function, that method, the instructions to open an Amazon box is unique to that Amazon box. Versus how to open a car door, that can be a totally another instance, and that can also have a to open method that is, the instructions are unique to how to open a car door. So, I don't know, does that kind of make sense?
Car door is still a class?
Yeah, so like a car door, like a car would have, a class of car would have like a to open method, and that method would have instructions to how to open, only how to open a car door. It wouldn't know how to open an Amazon box, a door to your house, whereas a function, just like basic functional programming, you're writing just function to open, would need to take in data on how to open like a car door, a front door, or an Amazon box. So it would have to know what type of data you're trying to open, what type of box you're trying to open. And that's where we get into scalability and stuff like that. So that's like the difference between object-oriented programming and functional programming. Where object-oriented programming, you're actually storing data about an object, like a car, a person, an animal, and that specific class or instance has attributes unique to that class. So let's jump into guessing game. All right. I am going to, and I noticed, I was looking at a bunch of people's pull requests, a good portion of you were writing unit tests, which is good, and we're going to cover unit tests for the guessing game as well once we get there. But for time's sake, we're going to go through the guessing game, and then we're going to write unit tests. Because we haven't really covered how to write unit tests for classes. We just know how to write unit tests for functions. So there is kind of a little hurdle there. So I'm on guessing game. I can fork it. Looks like I already forked it, but I haven't cloned it down to my local machine. I'm copying. And then I'm on desktop, Kilo Challenges, Anagrams, Armstrongs, and I want to git clone the guessing game. Guessing game opened up over here. Open up, we've got the README and the guessing game, but we don't have a spec file yet. I want to create a spec file. Touch, down here my touch, guessing game spec.py, and we'll get to writing test specs for the guessing game after we actually complete the guessing game. So let's look at what we're building. So this challenge will help you break down problems into implementable pseudocode, implement a basic Python class, and identify when to use instance variables. Richard, what's an instance variable?
An instance variable is, I guess, like an instance of that class. So like when you first build like the board and Boggle board, it's an instance of that board.
Okay.
That makes sense?
Yes.
Correct.
Great. Yep. So, and you can have multiple instances with multiple Boggle boards, but they're separate. So that instance variable is unique to that individual instance of the game Boggle board. Great. Use control flow iteration and iteration where appropriate. Explain how instance variables and methods represent the characteristics and actions of an object. All right, so what do we want to do first? What's the first step in writing a function or a method or anything? Like, thank you. Pseudocode. So in here we want to create a class. What is it? Guessing game. That should be initialized with an integer. Call something called answer or answer number. Class or guessing game should be initial. I'm just gonna actually copy all this because this is pretty much. Yeah. And just so I don't have to be switching back and forth. So guessing game should be initialized, an integer. Yeah, I'm just gonna use that. Define it. This is pretty much the pseudocode. Define an instance method. We'll get hashtag and documentation. Blah blah blah. So we'll actually get to actual pseudocode, the methods, because how the methods, individual methods operate. Like we still have to define that logic. So here's the guessing game class. So let's do this first one. We initialize with an integer. How do I initialize an instance variable? Def.
Double
Dunder init. What do I need? What are the arguments? Self. And let's call answer number. So right here, your guessing game should be initialized with an integer called something like answer or answer number. And this self, essentially you need to, this is going to be the first argument in all your methods within a class. It enables you to gain access to all the instance variables within that class. And what does this dunder init do? When does this run? Like when is this method executed?
When the class is called?
Correct, yeah. When the class is instantiated, that's like a term like when it's instantiated, this automatically runs. So we can call self.answer number equal answer number. And just so you, these two, they don't have to equal the same. So we can do like number and number, and it's still gonna operate the same. So we just like kind of keep everything uniform. So we kind of know specifically, oh, this answer number corresponds to this answer number. It's just easier to read for other developers. It's all about readability when other developers look at your code. So I'm going to bring that up. Great. So the second part, let's test this. I'm just going to run new game equals, how do I instantiate guessing game?
And you got to put the number.
All right, let's do 25. Now, how do I access, if I wanted to see what the answer number was, how do I
It's
show
new game dot answer number.
new game dot answer number?
And then parentheses.
Do I need parentheses?
Or those. Yeah. I'll put it.
So let's see what happens. CD, guessing game, ls. Oh, well, I clear the terminal. Now I'm going to run this and see what happens. Python guessing game dot py. Traceback says type int object not callable. So looks like line 9. Looks like this method is not callable because it's not a method. So I can have access to all. So I'm going to run down here again and run it.
New game dot answer number.
Yep. So it's not showing up. So I'm going to print the answer number. So you have access to all the instance variables of a class, essentially all the variables, whether it's a local variable or a class variable, by doing new game, which is the instance of guessing game, new game dot answer number, and it should print 25. There we go. So define an instance method, which takes an integer called user guessed as its input. Guess should return the string high. So let's return string high. The user guess is larger than the answer, correct if the user guess is equal to the answer, and low if the user guess is lower than the answer. So I'm going to do self. Is it guess? Nope. Def guess. What are the arguments I need to pass in to guess? Self. User guess. Okay, and now here I'm going to do some pseudo coding. So if user guess is greater than answer number, return I, else, so else if user guess equals answer, everything's gonna be like number, return correct, else. Do I even have to check? So if it's not greater than, doesn't equal, then it must be lower, right? So else, return low. So if user guess is greater than self dot answer number. So when I want to call or get access to an instance variable, I also always have to use the self keyword in front of the variable, no matter where I use it within the class object. Now, what would be user guess? What if I decided to like say guess equal user guess and use guess throughout the application? Oh, okay. Good call. So Daniel pointed out if I use the same, so I've got a method called guess. If I want to create a variable, also same as the method, it's going to run some issues. So I'm going to say, what's another selected? Whoop. Yeah, attempt. what is attempt? What kind of variable is that? It's a local variable. So attempt is different than an instance variable, where an instance variable is you're able to access this throughout the entire class within all their other methods within the class. Where attempt is called a local variable, which it's only bound to the context of this guess. So you're only able to access it within the guess method. Which also, so let's just, but we don't need to assign any local variables yet. But you can also create instance variables by doing self dot. Essentially, you're able to declare instance variables throughout other methods as well. So when this method is called guess, I can create like, say hello, goes I, and now I should be able to access this say hello instance variable throughout the entire class object. We can test that, but for this specific problem, we don't need to. So if user guess is greater than, return I. What, something just happened. Elif user guess equals self. Is this answer number? I don't know. Self dot answer number. Return correct. Else return low. So let's test this out. Now, how do I call the guess method on this new instance of this new game? Actually, instead of return, I also want to return some print statements. Print I. So I actually wanted to see it. Whoa. CD, guessing game. So I'm down here in my terminal. Oh, so how do I, Justin, how do I?
New game dot guess.
New game dot guess.
An argument of parentheses after.
So I need an argument because I need to pass in a user guess. So let's just pass in 20. What's the expected output? So Python user or guessing game. Oh no! Guessing game object has no attribute guess. Line 24. Oh, looks like. Does anybody know? So right now I'm calling this guess, and it's not finding this method. It's
There's spacing.
Thank you. Spacing, indentation is important in Python. So this was indented a little too far. Let's hopefully that. It's down here in the terminal. Let's re-execute. There we go. We got low. Let's look at the other. Solved. Okay. So define an instance method guessing game solved, which returns true if the most recent user guess was correct and false otherwise. I'm going to delete this. So we need to store. Yes. Oh, sorry. If we need to store whether the guessing the game has been solved or not, what's the best way to store that value? Where should we store it?
I just created a new variable and set it to false, and it stays at false until the game gets solved, at which point it switches to true.
Where should we create this variable?
right, I created right below def in it
Right
as
below.
the second line. On line 5, that's what I put.
On line 5?
Yeah.
Okay.
In the class so that guests could access it as well. So just,
And I put,
everything can access it. Yeah.
I just put solved status.
Solved status
Yes, equals false.
equals false. Okay.
And then on line,
I'm going to delete the pseudocode. Okay. And now how do we change this?
on line 12, I'll hit enter to create a new line.
On line 12, we're going to hit enter.
Yeah.
Okay.
And then I would set the solved status to true
Solved status
equals true.
equals true.
And then the exact same thing, but set to false on line 9.
You don't need to, it's already set false when you initiate it.
Yeah, but the problem is that if you run the game again, keep on running it, then it's gonna be set to true. If you solve it once, it will think that it's always solved forever, even if you do not solve it again.
No, because every time you run the game again, it's creating a new instance of the
Okay.
game.
Yeah.
Okay.
That's
All right. So let's look at define an instance method solve, which returns true if the most recent user guess was correct and false otherwise. So def solved self. Do I need to input any arguments other than self? Nope. And then if
isn't it just
It's
return?
just
It's just a return
return
statement.
Oh, okay,
Status.
self dot solve status.
And a print statement.
I'm going to do a print statement so it shows up down here in the terminal as well. Come down here. So we guessed 20. Let's see if it's solved. I need to invoke it because it's a method. It's a class method. What should this return? Low false. Let's see if it turns. Low false. Great. I'm down here. I'm going to, this is essentially, it's like driver code or runner code. Anytime you run this, it's going to essentially keep on running the game until we solve it. So last guess, input. What is this import random?
It's a class. It's a module that gets imported at the beginning of the script if it's on line 1.
If this random is like a built-in package in Python that enables you to, what is it, grab a random integer. Looks like it grabs a random integer between 1 and 100. Great. Let's see if this is going to work. So I see, well, game solved. So our code, this runner code is not compatible with what we just wrote, really. Is it while? So I think that while loop. Let's do not equals none. So let's look here. Instantiates a new game called guessing game. It takes in a random number between 1 and 100. Has 2 variables, last guess, none. Last result, none. And so when this file is executed, it comes into this while loop, while game.solved. So game.solved, so it's going to come up here, game.return solved status. So the solved status is false.
So game that's all status.
Oh, yep, so right here, we can do game.solve, or we can invoke solved, because solved is a method, or we have access to solve status instance variable like that. So I'll solve status equals false. If last guess does not equal none, so right now it does equal none. So the first time it runs through, So it equals none. So it's going to skip this if statement. It's going to come over here, takes this last guess, takes in an input, enter your guess, and then it assigns it to the last guess. And then so your last guess will be whatever your last guess was. Then it's going to come over here. It's going to execute game.guess. It's going to pass in this last guess, which is input by the user, and assign it to last result. And then when this guess is executed, it's going to come up here. It's going to pass in the user guess, and it's going to run through this logic. If it's solved, it's going to turn the solve status to true. If it's not, it's just going to stay false. So it's going to continue executing this while loop. Let's see what happens. Think we'll get any errors? Enter your guess.
Can you lift that up?
K.
Oh, sorry.
Put a K in there.
Let's first work with numbers, and then let's do edge cases afterwards. 25. I'm going to do, it's 1 through 100. Let's try to guess it. Oh, shoot. So file, the first thing you want to read, like when you're debugging, is your traceback. Like, let's see where this error occurred. File guessing game pi. Okay, we're in the guessing game pi. Line 39. So right here, and it says line, so then it goes line 10 and guess. It's up here in line 10. If user guess is greater than self.answer, right here, and it says type error greater than not supported between instances of string and integer. So it looks like our input.
Yeah, because your input should be integer.
Okay. How do we? I want to see what that looks like. Is it type? Last guess. So I just want to see what the input, the type of this is, to ensure that it's in fact a string. And so I'm going to run this again. Do 50. All right. So here's my guess. Here's my print thing. Okay, the class, it's a string.
So you put in INT before 460.
Great. So Steven's saying we can convert it into an integer by putting int in front of the input to convert it to an integer right away. See if that works. Clear. Execute the code. To your guess, 50. Oops. All right. Oops, it was high. The last guess was 50 was high. Let's guess again. I'm going to guess 25. Still high. What is it, 12? I get it. Low. What is it? 19. Low. 23. Too high. 21. Oh my gosh. So it's 20. Correct. All right. Our code works. Now let's run this code again. Let's put like J. All right, yeah, so J. So if you type in a string of any kind, it's going to blow up. So it's kind of like an edge case. Obviously, if you're playing this game, pick a number between 1 and 100. Hopefully someone's not going to be like R. That's not. So let's just assume that.
Should we try to put throw errors in?
You can. Let's. So you'd have to like take the input and run some other logic in your guess, like if type. So since we can't, if we want to account for integers, we wouldn't convert it here. We convert it up here in our guess. So if type user guess equals, what is it, string, like that.
You can also do try and set.
Oh, you can also.
Is it even going to get to line 10 if when you type in the input as a string, it's going to break before line 10.
No, it broke right here before, so it should get here.
When you scroll down to the input,
So
you remove the integer.
so I removed the integer because right up here is where I want to test it. Like return input must be an integer, something like that. Well, does that even work? No, because it's always going to be an integer. Yeah, you just do like a try except. But let's just assume that you're not going to guess a non-integer.
J in the numbers game.
Yep. So let's go over to our spec file. We want to write some test specs for this guessing game class. So what's the first thing we need to do to create a test spec? We have to import our libraries. So import unit test. I always do unit test, like import unit test. What else do we need to import? Import the class. So we have to import this guessing game.
From
Guessing game. Whoop.
we'll set the read in our file.
From guessing game.
That'll be from first, right?
Does that work? That should work. And if it doesn't, we'll figure it out. So we need to create a class. Class guessing game test case unit test dot test case. This is all just built-in methods within unit test library. So now do kind of classes make sense when we're doing unit tests? Like the first time you've seen this unit test. So first we're going to create a test returns hi. I'm just going to copy it. Well, returns hi, self. These three quotes in a row, it's just kind of like comment when user guesses 20, it's going to return. Whoa. This is what I want this test to do. Self.assert equal. Now, what do I pass into here? How do I instantiate a new guessing game?
That's what challenged me yesterday, is that I learned that you have to initialize the game before you begin testing it, so that on line 3 you will have to start a new game.
Okay. So on line 3, we can do it in line 3, but we want to keep all the variables and all instantiations within the test case.
Oh, okay.
So there is a way, every time a test case is ran, to run code before the test case. Like before this test case is ran, we can run some code to set up our test case. So I'm going to just look at unit test Python. Is it unit test? I just want to see if there's anything in here. So as I said before, software development's 80% reading, 20% actually coding. So here's like a good example of a basic test case. Looks like I need this main. I forgot to put that down here. Do that. Go down here. Command line interface, cool. Not seeing anything. Test discovery, nothing. Tests can be numerous and their setup can be repetitive. So luckily we can factor out setup code by implementing a method called setup, which the testing framework will automatically call for every single test we run. Great. So I'm going to copy this. The setup is a built-in method within unit test. I'm going to copy it right there. So instead of widget, this widget class, let's just self.new game equal guessing game. Let's do, we want user guess 20 to return low, so let's guess 30. So in order to access the instance, this new game, self.new game, what is it? Do I do guess? I don't know, because I want to have this return low, so I need to call this the guess method. And what's lower than 30? I want to see if it returns low. Let's run this and see what happens. Python, down here in the terminal, I'm going to clear it. Python, guessing game, spec. Oh no, invalid syntax. What's going on? Oh, does anybody see? This happens, I'm used to JavaScript. Is it back? It's backwards. Yes. Oh no. So what it's doing right now, so it's telling me to enter my guess, but I just ran my unit test. So since I imported, the way Python works is anytime you import from another file, it automatically runs the file you're importing. So it automatically runs all the code in this file. And in this file, I have all this runner code. So let's delete all this. We don't need this.
You could just save it for later, but with the three, you know what I'm talking about, the three thingies?
Right here? The three thingies?
Yeah, that's
Is this what you're talking about?
yeah, actually, just comment. Yeah.
Oh, I can, oh, okay.
Yeah.
I actually just want to comment it out, or I just want to delete it because I don't necessarily need that for later or anything.
What did setup do again?
Setup, this, it's,
Initializing.
it's initializing a new instance every time a test is ran. So it runs this code before every single test I run. So here's a test. So it runs this code, then runs this test. And then if I write another piece of test, another test case, it'll run this code again and then run the next test case.
Reading a class every time you
Correct.
create an instance.
Or yeah. So I'm gonna exit out of there. I'm gonna clear it because I don't want that code to run. I'm gonna run the spec file low. Great. So low. Why is this printing out? It's probably because up here I've got these print statements. I don't need the print statements anymore because that's just for me to see on the terminal. I'm gonna remove all these print statements. Keep your code clean. Get remove console logs, remove print statements. We're going to run this spec again. One test ran. Okay. What other thing do you want to test? Just turn low. Want to return. Oh wait, this is wrong. This should be say return low, right? Returns low, 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 returns high. High. We're guessing 30. Let's guess 40. 40. Let's run another one. 2 tests ran. Great. Returns correct. Let's do 30. Correct. 30, correct, clear, run this again. So essentially kind of what I'm doing is writing, this is kind of like what you're not supposed to do in test-driven development, because it kind of making it fit what I already written. If I saw Stephen yesterday doing test-driven development. Props to Stephen for doing that because he was writing his test cases and then writing his function or his case as he was writing some test cases, making his code to match his test cases. And that's how you're supposed to do it. So props to Stephen for doing that. But let's run this. Okay, we got 3 test cases. What else can we test? Whether it's solved or not. We can do is solved is our solve status to return false.
Are we going to use the sort equal the most, or is it just the things we're currently doing seem to default to sort equal?
It works right now, like what we're looking at. You can do like not equal. We can run tests that's like to certain not equal. It can be a bunch of stuff. But right now, just for simplicity purposes, we're using assert equal. So now I actually got 6 different things I'm testing. Whether the solve status is false, whether it's going to return low, as well as whether it's going to return false, high, false, correct, and true. But there's still only 3 test specs. All right, 3 test specs ran. Remote, what questions do you have from classes, object-oriented programming, or unit tests? What questions do you have? What is a unit test? Jorge, what's a unit test? Yeah.
I think it's a module that gets imported from Python to specifically test cases like that.
Yeah. All right. Great. Both answers are 100% correct. So yeah, unit test is also a library. That was kind of like what is this individual unit test?
What's the difference between a module and library?
I don't know. I don't know if there is one. There's like libraries, packages, modules. You'll use packages and libraries interchangeably. And then there's frameworks, which is a whole other thing we'll get into. Yes.
Nothing to do with the topic itself. But how did you move like the whole block in Python, like indentation, like sometimes it's off, then you move the whole block and indented it perfectly?
So the question is, how did I move an entire block from indenting? Is that correct?
Yeah.
So I just highlighted the entire block and I do tab, and if I want to move back, I do hold shift tab to get it back in line with the shift tab to the right. I'm sorry, tab to the right, shift tab to the left. If nobody has any more questions, I'm going to stop the recording there. I'm going to take a 10-minute break.